Hello everybody, I wish you're doing well. Today I will teach you how to machine a single blade. To do this, I have prepared to you a workpiece called Turbine blade that I will put in description. So we will do this blade with the use of this strategy called single blade finishing. So to start, we have imported. Here is the blade. Today we will machine just this part of the blade, but tell me in the comments if you want that we do also this part. So let's start. So we will create our block. Calculate it. Here is our block. We will put it on global transform. Then we'll accept. Then now we will create a work plane. So we'll choose to put it here. Then I will activate it. We can see here that it is aligned on Y, but we will see next time how, because we must align it on Z to machine all the blade. If we don't do it, we'll just machine a part of this blade. So now we will start our machining with creating our first toolpath. So we will choose to do our first machining with simple finishing, with rotatory finishing. So we will click here. We will create also a tool. Put it on. Let's put this. Create directly a tool from here. Let's create a ball nose one. Let's clear the tool that we have created here. So let's name it one directly from here. Create a tool of 16 diameter and length of 18. Then let's create a shank, then a holder, or let's put 120, not 120 here, but 100 and 120 here. Let's create also, I think, then now, so we'll go to our, so we have our tool here. So we have our work plane. Then now we will choose to do it in spiral. We see our limits like this. To refinishing, we'll put a thickness of maybe not 1 millimeter, but let's put a half millimeter. Let's calculate and see what we will have. I don't want it from this direction, so maybe the problem is this, or so let's twist it around Z. Let's put X like this. So here what we will have, so we'll limit it in this. So to see the limit here, what is limit? We can see that here highest point is around 14. For to erase this, start we'll start from minus 14 maybe. Not this, but here we'll put 0. So here we must do plus 14. So this is it. We'll do this. So we'll do our machining. Let's see it. So we'll have something like this. So this is it for our first machining. It is just to show you. Then now what we will do, it's we will create a new toolpath. But before creating this toolpath, we have to create a work plane that we will put in the same place here, but we have to turn. We have to turn and put Z in this direction. So let's twist around Y. So this is it. So we'll accept it. Then we must do something. So here, the connection, we have to change them. So to change the connection, we have to activate the rapid surface and the plunge surface to see them. So I'll put it on cylinder, then we'll see that the cylinder is developed here, but we need it around Z. So here we'll put it on 0, there we'll put it on 1, so it is developed around Z. So let's calculate, and we will have rapid surfaces and plunge surfaces done like this. So we will apply it and accept it. So we must calculate this. So let's recalculate it, or let's just see the plunge surfaces. So we'll have to set them up for this cylinder 1. So let's calculate. So we must, so Z is here, so we have to put it into X for this and 0 for this, and calculate. And apply it and accept it for this. So this is it. Let's create a new toolpath. So we'll create it from here. So this second toolpath will be a single blade finishing. Okay, so before we do this, we have to create a pattern here. So let's hide this and create our pattern. So before this, I want to recheck this. So let's calculate it. If we put it on global transform, the Y is the main direction that we want. So we'll calculate it and apply it and just put this in global transform. So we won't have problems. Then now, as I told you, we have to create a pattern. So a composite curve, we'll click on this and just click here. It will do all the job. Then we'll create a composite curve a second time. Click here and click here, and we'll have it a second time. So to do the machining, we must have at least 3 curves, a start curve, an end curve, and a not closed curve, but an opened one that will be the directory curve. It has its specific name here, so we will go directly to this. So status is valid. We have a new button here. We can click on it. We can, for example, select the start curve. I can select this. Select the end curve. We can select this one, and select seam curve. They call it the seam curve, and select it. It is here directly. But if we need to change, for example, we can select this and click, and it will change. We can, for example, swap between drive curves. We can change the cut direction. Can also machine the reverse machining side. So we will accept it, and it is good that we put here in spiral and put the step over on 10, so it won't take a lot of time to machine. But I'll show you a problem when we do directly calculate. Yeah, we have a problem here. So the work plane, we must choose the second where Z is aligned. So when with these parameters, when we put the thickness on 0, of course, then when we calculate, It will take a little bit of time because it is a really developed developed toolpath to be generated. As you see here, we have complex curves and complex complex shape of this blade. So we will have all this because we didn't choose one thing. So we'll have all these air cutting and problems. In reality, we can do it like this. So what we will do is to change the tool axis. So we will put it on lead and lean and put it on PowerMill 2012 R2. Then we will calculate. I wish it will be faster, or we will wait for it. So we will have this spirals. We can also optimize this machining with choosing here links as a circular arc, and here in scheme, but we won't do it, we won't calculate it because it will take a lot of time. So here it is, our machining. We can simulate it. We will maybe have some problems, but it is our machine. We'll put it on a small speed. It will do this. It will machine here the extra DOS, and here it will machine the intra DOS with a lower speed, here with a higher speed, because it will do more distance, so it will turn more here, but as we can see here, it has the same speed in blade. So this is it. We'll do the same as the as you know in aerodynamics, when air go in the blade here, it will go faster because it has a lot of distance to do, and there it will go with a lower speed, and because of Bernoulli's law, so we'll have a depression here and depression here, so it will give us a force that goes from here to here. So let's simulate it with a machine. I will import a machine. I have my own machine here, and I will create its work plane. So I will choose a point here, just put it here. So for machine tool, it is like this. So let's see what we can do with the machine tool. Or let's simulate all from the start with the block. We'll have problems, I think, but let's just see this. It is not the best thing to do to go directly from here. It is better to go from here and don't attack the material like this, but it is just to show you we are not optimizing our machine in here. So here is the first step. So here the machine can't get to this value because the minimum is this. This in the programmation of the machine. So let's put a lower speed. Less speed. So in reality, we have this. Of course, we can put more step down to have a better surface. So this is the machining of a blade, and this is how we use single blade machining. Thank you for watching, and see you soon.